Hello guys, this is Vamsi. Now we are discussing about the project of recurrent neural networks for a sequence data. In this project we have 5 parts, and the first part is about the full sample of rental contracts with 14,918 observations and 17 variables. The data is from the year 1974 to 2015, and the different columns in the dataset along with the data type are as follows. The shape of the dataset is 14,918.14, and the dataset is numeral. The source we have taken from is like decline discount rates in Singapore's market for privately developed apartments. In part 2, we can see the simple RNN with sine wave data and the diagram of the designed RNN network and number of neurons in the simple RNN layer of the design network is 64. Now you can see the diagram. Results. Imported all acquired libraries for this project. Create a simple sine wave using NumPy, and the sine wave is plotted. The sine wave data is loaded into a pandas data frame, and the length of the data frame is like 780. Fitting of data is done now. The test percentage is like 25%. So the test length will be 25% of 780, which is 195. And the test data starts at 585 index. We have now created separate testing training data sets from the original data set. Next step that is done is numerize and the data into the range. For this, the min-max scale is used. Here the training data and the test data is normalized separately. A time series generator instance is created to generate time series batches for training and testing. 60 historical data points are used to predict the next one, and only one sample is used in a batch. Time series generator for training dataset is generated to train the model, and the length of the series is 585. Just to see how the batches look like, the front batch is printed. Before we can see the size of the design of the network. Simple RNN layer of the design network is like 64. And here we can see that the test data starts at 585 index. And the length of this series is like 585. Now comes building the RNN model. The RNN model has two layers. One is simple RNN layer, and that has 64 neurons, and the next is fully connected layer. Like we said before, like the number of neurons in the simple RNN layer for the design network is 64. Now the model is built. Now we have to compile the model. Here Adam optimizer mesfer loss function are used. Next step is to fit the model. Number of approaches is 10. Time series generator is used here. In this, we have used the time series generator. and mesh for the loss function are also used. So after training, the model performance is visualized. The loss dropped quickly during the first approach. Then there was no much chance in the loss. Evaluated the model on test data to check how better the model learned. In the new data frame, we have sign values and the pattern values made by the model are loaded. In the new data frame, we have the sign values and the predicted values. Now this new data frame is plotted. The predicted waves sometimes underwent the original sine wave and sometimes overwent the original sine wave. Like it deviates up and down. Because of the two layers, we have used like RNN layer and that have 64 neurons, which is fully connected. In this new data frame is plotted. The predicted wave sometimes it went underwent and the original sine wave and sometimes overwent to the original sine wave. Now coming to part 3. In part 3 we have taken the RNN neural networks, vanishing gradient problems. The problems are like the vanishing gradient occurs when during backdrop the error signal used to train the network drops apparently as you move backwards in your network. As a result, the layer closest to your input and are not learned. The guidance of the loss function approach when more layers with specific activation functions are added to neural networks, making the networks difficult to train. The functions, for example, sequence a wide input file into a small input area between 0 and 1. As a result, a certain change in the signal function's input will result in a mode exchange in the output. As a result, the deviation becomes small. The below image shows the vanished guidance problems. The problems the lower closer to your input are not learned. The guidance of the low function approach 0 when more layers with specific activation function are added. So when many layers are added, so it will be more difficult to move to make the network difficult to train. Sequence a wide input field into a small input area between 0 and 1. So it results will change the output. So you can see in this graph like exploding guidance problem. Like the red line will be the activation function and the blue wave is like deviation. So when the network drops apparently as you move backwards in the network, as a result in the layer closer to the input are not learned. So when the input fill into a small input area between 0 and 1, it moves upwards and backwards. The below the mode is change in the output. As a result, the deviation becomes small. So like it will become small. So parameter will be like 1.0. So you can see the blue line, which is derivative. When Hughes error guidance build and